All right, today we're pulling back the curtain on a little piece of digital magic. You know that button you press all the time, maybe without even thinking about it? Yep, we're going to explore the simple but super powerful idea that makes your undo button work.
I mean, have you ever really thought about it? You type a whole paragraph, delete a file by accident, make some kind of mistake, and boom, Control-Z, and it's like it never even happened. It's wild. How in the world does your computer know what your last action was and how to reverse it?
Well, the secret isn't some crazy, complicated algorithm. Believe it or not, it's an idea you already know from your everyday life. Just picture a stack of plates or a pile of books. Heck, even your browser's back button. They all work on the exact same super simple rule. And that rule, it's called last in, first out. That's it. This is the absolute core concept, the one simple idea that makes the whole thing tick. So let's break down exactly what that means.
Okay, so in the world of computer science, this structure has a name. It's called a stack. And its guiding principle is what we call LIFO. That's L-I-F-O, which stands for last in, first out. It's a really simple rule. Whatever you put in last is always, always the first thing you have to take out.
So let's make this idea a little less abstract and more concrete. Imagine you're washing dishes. You put the first clean plate down on the counter. Then you place a second plate right on top of it. Now, if you need a plate, you can't just yank the bottom one out, right? Of course not. You have to take the top one, plate 2, the one you just put there. Only then can you get to plate 1. See? That's it. Last in, first out.
Okay, now that we've got the basic idea down, let's learn the official lingo. You know, programmers don't really talk about placing plates and taking plates. They've got a couple of specific terms for these actions. So, the three main operations are called push, pop, and peek. Push is just the fancy word for adding a new plate to the top of the stack. Pop is when you remove that top plate. And peek? Well, that's like taking a quick look at the top plate without actually taking it off. And this is important. Look at the danger next to pop. Underflow. That's a classic computer error. It happens when you try to pop from an empty stack. It's literally like trying to grab a plate when the counter is already bare.
And this brings us to a golden rule, a really critical one. A program has to check if the stack is empty before it tries to pop anything. It's a super simple check, but it's what prevents crashes and keeps everything running the way it's supposed to.
All right, now this is where it gets really, really cool. Let's see how this simple analogy of stacking plates translates directly into actual, powerful, working code.
And you're going to love how intuitive this is. To push an item onto our stack in Python, we just use a method called append. That's it. It just adds the new thing to the end of our list, and that end of the list basically becomes the top of our stack. Simple as that.
And popping, it's just as easy. Python has a built-in pop method that automatically removes the very last item from the list. You don't have to do anything special. The programming language itself is designed to handle that whole last in, first out rule for us. It's pretty great.
Okay, let's actually watch this work. We'll run a quick little simulation here. First, we're going to start with a totally empty stack, which, in the world of Python, is just an empty list.
Okay, first, let's push the number 10 onto our stack. Next, we'll push 20 so it lands right on top of the 10. And finally, we push 30. So take a look at the order in our list now. It's 10, then 20, then 30. The last number we put in was 30. Remember that.
All right, here we go, moment of truth. Based on everything we've talked about, that whole LIFO principle, if we perform a pop operation right now, what number do you think is going to come off?
You got it, it's 30. The last item we pushed onto the stack is the very first one to be popped off. That is last in, first out in action, right there.
And of course, after we pop that 30 off, what's our stack left with? Just the first two items we added, 10 and 20. It works absolutely perfectly. Okay, so now that you get the mechanics, let's zoom back out to the big picture. Because once you see this last in, first out pattern, you're going to start realizing this simple idea isn't just for coding. I'm telling you, it's absolutely everywhere.
Think about it. This one concept, the stack, is the engine behind so many things we just take for granted. Every single time you hit undo, what you're really doing is popping your last action off a stack. Every time you click the back button in your browser, you're just popping a web page off a stack. This idea is so fundamental, it even controls how computer programs manage their tasks deep, deep down.
And you know, that's the real takeaway here. So much of our most complex technology is actually built on layers of these surprisingly simple, really elegant ideas. The undo button isn't magic. It's just a stack of plates. And it really makes you wonder, doesn't it? What other simple ideas like this are hiding in plain sight, powering the technology we use every single day?